Hello everybody and welcome to the Streamline for Unity demo. In this video we're going to be going over how to set up Streamline for Unity and also how to create this portal system here using Streamline for Unity at the end of the video, so make sure to stay tuned to go and check this out. With that, let's get started. So here in the Unity editor, you can see we have our demo scene. This is just displaying from the game camera right now, but we can go over to our scene and we can see that Streamline for Unity is helping create this visual effects system here that kind of creates a oval-like portal. And we can see this is just being driven off of the spline right here that is in the shape of the oval. And so what Streamline for Unity does is it takes splines like these and uses them to drive visual effects inside Unity through the visual effect graph. This functionality is not included by default in Unity, and so that's what this asset package does, is it adds ways where you can use splines to influence and create your visual effects within Unity using the splines package that Unity comes with. So let's get started with how to implement it into any project that you're using. So what you will do is you will go up to your asset store, and then you will head over to My Assets, and then go ahead and import Streamline once you have it. And then when you import it, it should show up similar to this, where you will have a Streamline folder here, and then it will come with an Assets folder, an Example folder, and then some very basic documentation, as well as the component it comes with, and a base visual effect graph that you can work off of. So in this example, it just includes the example level and example emitters that are in the example level. We're not going to be going over that here. You can go and check that out yourself. But what this product's main feature is this Streamline component here. So if we want to create any Streamline system, what we need to do first is we need to have a game object to add this component to. So I'm going to go over here and create a new empty game object. I will just call this Streamline object. And so right now we just have a transform here. However, if we go and we can go to Effects and Streamline Spline Emission, and this will add our Streamline component, and it's way down here at the bottom. You'll notice it default adds the visual effects and spline container. An important thing to note for this is that you have your splines package installed as well as your visual effects package. You can check this by going to Window Package Manager and then going and searching the Unity registry for the splines package and the visual effects package. I am in the high definition render pipeline right now that should come with the visual effects package already installed. However, you may need to install the spline package, and you will notice that you will need to install the spline package because Streamline will give you an error on import saying it can't find the splines namespace or something like that. And so all you need to do to fix that is just go up here and install the splines package. Everything will be fixed and it will work as intended. So first of all, if we look here, this game object, now we can see it has a visual effects component as by the icon there. And so we can look at this. We have a visual effect asset and a spline container. There's no spline right now though. So that is something we will need to get to, is creating the splines. So to create a spline, let's go and click on the add button for the splines array. And this adds our first knot to the spline. If you're not familiar with the spline system in Unity, I highly suggest you go check out different tutorials for how to get started with that. You can go check out the documentation directly from the splines package that is right here in Unity. You can also just go online and look up. There's all kinds of different tutorials, people that will show you how to get started on it. We're going to assume that you have a basic understanding of splines. So we have our first knot here. We can add a second knot, and you can see we obviously have a line here. And this is our spline. We can go to the spline edit mode and we can see it is composed of these two keyframe points in the spline basically. They both have their respective tangents if need be. So that's our spline setup. And then we can use Streamline here to control the entire rest of this game object. And so first of all, we'll see the visual effects graph. This is where you plug in the visual effects graph that uses any Streamline data in it. And then down here, this is debug spline visualization. We'll talk about that a little bit later when we're creating the portal, but this is very useful when you are creating with your splines so that you can kind of see what Streamline sees when it looks at the splines and how it will be interpreting your data. So that is very useful. This is one of the other most important settings on this component is the spline subdivision field. And this says how many sampling points throughout the spline are we going to be looking at, because Streamline takes your spline and breaks it into its different values and sends that over to the visual effects system. So this is basically saying how many points do I want to directly sample on this spline, and then anywhere in between these points is interpolated based on what it gets off of these points. So right now I am taking this whole spline and I'm splitting it into 30 different sections when I'm sampling it. So every time it updates the information with the spline, it is looking at 30 different points all along this spline here, taking data from those and then interpolating between them to essentially recreate the spline in its data for the visual effects assets. So we can turn this down, and you can turn this down all the way to 1, and this will basically just sample the endpoints of the spline, and you'll just have a flat line. Generally not very useful, but you can keep it at a pretty low number, like anywhere between 1 to 10, and you can get a very blocky spline, if you will, and this is very helpful. If you want something to kind of be, I guess, stylized in a way, you can have your splines be sampled at different levels of detail, but the default's at 30, and we will be keeping it there for the sake of this video. Next is the coordinate space. This just says, do we want to sample it in the world space? So the position and rotation data that we send, do we want that data to be in reference to the global scene, or do you want that to just be local to the game object and it will send variations of data based on which one of these you have selected? Next is the data sends. This is very important because this says what data your visual effect asset will be able to access. And this is just for saving resources and making it pretty easy on your system. This way you only need to worry about calculating what you actually need from the spline, and you can save time when it comes to calculating other things. This down here, we'll get into this a bit later when we show you what it looks like when the data is sent. But what this does is this basically bakes the calculated tangents from this into the position that it sends as well. And this ensures that the position will interpolate just a bit smoother and look a bit more like the spline. Next is the proximity target location. And so this is just a vector value, and at 0, it doesn't do anything. However, when it's not 0, what it does is it will say, where is the closest point on this spline to this location right here? And then it will be able to send the vector that is the location closest on the spline to this vector into the visual effects system, as long as you have the proximity target point checked, of course. You can also just use an object instead. So if you put in another game object, it will take that game object's transform and use it instead of this location. If you put in any game object here, it will automatically override the location you have set here. So keep that in mind. Lastly, you'll also need to check use proximity targeting if you want to use this at all as well down here. And then you can also check use smooth proximity targeting. So by default, proximity targeting will clamp itself basically to the set of these points that it is sampled. So I can only get the closest point if it is one of these 30 points. It will always find one, but it will only be one of these 30 points. However, if I check use smooth proximity targeting, what it will then do is it will also take the interpolation into account and say, okay, it's not quite point 21 or 22, so it will land it in the middle instead of choosing one or the other. Okay, so let's go ahead and see what it's like when we add a visual effect asset to it. We can look here, we have our default asset set up. So the default visual effect asset that comes with this is the Streamline VFX visual effect asset. So when we add this, we can see it's added there, and we can also see it has already been added up here in the visual effects. And close this out. Right now, we will see it's just kind of flowing out from right here. And that is not very useful. That is not even where our spline is. How do we fix that? We need to remember to turn on our sampled spline points here, and this will send the position data. And now we can see our particles are spawning off of this spline and kind of just gently falling down, only along where the spline is, just kind of at random. So this is just about as basic of a system as you can make with Streamline. It's a pretty good start. It can take just seconds to do this, and this will honestly save you a lot of time. So we can look over here at the properties and what it is sending, and we can see here that these are all unchecked. These properties are not being sent to our system. However, it is receiving properties for position, the X, Y, and Z of the spline. So we can look, we can see the position X of the spline is changing over time quite linearly. We can see it's sampled and that it is a pretty consistent line. And then these other ones do not change over time. It is just a flat line. And to go a bit further into what the spline is doing here, this is basically sampled over the T coordinate of the spline from 0 to 1. And this way it's a way of reconstructing the spline inside of the visual effect asset because it does not natively have support for a spline structure inside of it. So this is how you can still get the spline data to it. Next, we can go ahead and see what our debug spline visualization does really quickly here. So if I check this, we can see it displays this set of lines here. These are the axes at every spline point. Our green is the up vector, blue is the right vector, which is internally called the tangent in this system. And our red is our direction vector, what is traditionally measured as the tangent. And so this will go away after a quick while. It only renders it for about 20 or 30 seconds. And just uncheck that. Or this visualization will change when you move these around. So if we add on another point and I say move this point this way, this point this way, and up, we get curve more like this. And if we go and check the spline visualization, we can see that these axes are changing along the spline. It's basically a coordinate system at every individual point that you can see. And that will define how the spline is oriented at that point. And you can get a lot of data out of this, so it is always very useful to have these things sent to your visual effects system. So let's go and create our own system so we can see just a bit more of what is going on inside with all of this data. So we can go ahead, right-click, create, visual effects, visual effect graph. And then we can go, and Streamline comes by default built in with its visual effects template. And so this is the just the base template for Streamline, and it comes already with the values necessary. So I will call this just our test system. So I will open it up right here, and we can see inside of our graph, it comes, you will have a just a little example here of all the properties it can use, and you can see they're already auto-loaded in. You should not change these names because then data will not be sent to the correct location, so make sure you leave these the same. However, if you know you're not going to be using a certain data type in this, like let's say I know I'm not going to be using any of the rotations, I can go ahead and delete the roll, the pitch, and the yaw, and I don't need to worry about those because I know that I will not be needing them in my system at all, so we can just ignore them and clean the system up by getting rid of them. So we can go ahead and look at our system here, and we can see it's a pretty normal system, all things considered. It just spawns in particles, gives them their life and velocity, and then gravity just brings them downwards, some turbulence to make it look interesting, and aerial drag, and then it just renders them out like so. Where Streamline comes in is this follow spline block here. We can see we input a spline T coordinate, which is that position from 0 to 1 along the spline, and we're just picking a random value here. So anywhere random between 0 and 1, it will draw for every particle. And then we plug in our spline's position, and then inside of here, it reconstructs the spline, and then we'll find that random coordinate in there. And then it will place the particle on that coordinate, and then the rest of the system proceeds like so. So this is pretty simple, and you can see it's just a very quick in out of the data. Position goes in, and then it spits out the position where the particle should be. Now Streamline does come with all kinds of different operators and blocks that you can use inside of your visual effects graph. It is not just used for getting splines into the graph. You can use all kinds of different Streamline things inside of it. So in the case of outside of our blockchain here, we can look at the different operators we have. A lot of them deal with splines. A couple of them are just for utilities that are used commonly with splines, such as 2 radians and degrees. That's just useful to have around and is not by default in the visual effects graph. You can get some extensions that will have that, but this is meant to run off of the bare bones implementation of the VFX graph to be the most effective, so it will come with these things by itself. We also have other helper functions like random point and circle and rotate angle over axis. You do not need to worry about those, but if you want to, you can go ahead and use them as well. What Streamline adds that is most useful is these operators right here. All these different operators perform different things based on the inputs. So for example, if I chose the spline over sample, we can look here and we will see it takes in the position of the spline, a t coordinate for that spline, and then how to oversample the spline, and then it will output a position based on all of that input data. So Streamline has several operators like that, and it also has blocks. So I can actually go here, remove the follow spline, and we can add a block from the subgraph blocks drop down here. We have several options for Streamline. These are not the only ones. These are just the ones that are available in the update module. The Streamline also comes with more in the render module as well. Not all are able to be in the initialization, update, and render. Some can only be in specific modules of this. But anyways, let's go ahead and add in a shape position spline. So this is very similar to any other position shape that you will be working with, except it just uses the spline as the position to put the particles on. We can go ahead and add this in, and we will see this might look pretty daunting at first. This is a lot of information here, after all, that you need to set and deal with. But overall, it is pretty simple. And so what we can do actually to mimic the follow spline module is with this, we can have a distribution type of random. So this top section, this basically distributes the particles along that spline. So we can have them distributed at random u coordinates across this range from the minimum to maximum t coordinate. We can also distribute them uniformly across this range where particles are set at even intervals throughout it, or we can directly distribute all the particles at 1 u coordinate. Right now, we're just going to leave it at random. This means we don't need our random float anymore because this is now doing all the randomization work, so we can delete this. Now all we need to do is plug our positions into this block, save that, and we can go check out the scene, and we can see the particles are still falling off the spline as if we had the old block still in place, but we are using a different block now. And so this is a very helpful block, probably one of the most helpful ones in all of Streamline, because it does take care of a lot of the heavy lifting of spline interpretation inside of the visual effects graph. In addition to this, it will also do radius calculations when you plug in the directions and up vectors and specify radius. And then you can also transform that spline shape anywhere you want as well, and scale it and rotate it, of course. And then you can also decide whether or not you want that to take place in local or world space. Anyways, that covers most of the bare bones basics of Streamline. You basically have your component that you add on to an object, and then that component will send all of this data into your visual effects system that you have, as long as the visual effects system has the correct parameters, of course, to receive this data. And then inside of the visual effects graph that you make, you can go ahead and use Streamline inside of here to further use the spline data and create very advanced visual effects systems that use splines and honestly look very unique, especially when you consider that there's not a lot of ways to do this in Unity. Anyways, with that, let's get into how to make a portal like this using Streamline. So first things first, we can go over and we will need to create a new system for this. So I will go to Create, Visual Effects Graph. I will create from the Streamline template again, and I will name this Portal Tutorial. We can open up our Portal Tutorial, close our old system here. We'll just leave it as is for now. We don't need to worry about this. Right now, what we want to do is set this up. So why Streamline is very special here is that we can define any shape for our portal. In a lot of visual effects, you'll see some portals that will use just very basic shapes for something like this, usually a perfect circle, something like a cube, some very regular shape. However, with Streamline, you can define any shape you want with a spline. For example, this oval. This is not quite as easy to achieve with regular visual effects in Unity because there's no way to, by default, have any way of defining ovals or ellipses in Unity's visual effects system. But all you need to do with Streamline is you need to draw it out with a spline, and then you will have your shape, and then you can use that shape's properties to influence the particles. So what I did ahead of time is I prepared this portal mesh here just to kind of frame the effect and, you know, make it look like it's not just floating in the air. And it really does, in my opinion, contribute to this effect greatly. The other thing I did, obviously, was I created this oval ahead of time. Again, you can use any shape you want. I will go over the specifics of how to construct shapes like these to ensure that this portal effect works properly, because you do need to have your splines in the correct format for this to work. Otherwise, you may get particles spraying in directions you did not intend. So what I will do is I will create our empty object, and I will call this portal effects. And I will also go ahead and parent this to our portal that is right here. I will move this into position more or less in the center of the portal right there. And I will go ahead and add the Streamline component. So what you can do for this is you will first need to make your spline for this. I won't go over how to specifically make the spline. You can make it whatever shape you want, and if you are unfamiliar with how to use your spline editing tool, I highly suggest you go check out a YouTube tutorial or something on that. You should be able to find something that's pretty comprehensive and get you on the right path for that right away. What I'm going to do for the sake of time is I'm going to basically duplicate this spline that we have over here. So what I'm going to do is I'm just going to take the values I have here. You can also look at these values too and set up your own spline this way, but I'm going to just really quickly with this system go ahead and set up the spline. So I will create a new spline. It'll have 4 knots. I'm just going to be copy pasting all of these values. You can go ahead and look at them yourself if you want, but I will cut ahead to when I am done building this, and I will show you what I looked for when I built it. Okay, I am done building the spline for this portal. And so as you can see, we just have an oval. And what I did was, this is important to note, I made sure to submerge the spline itself into the mesh. This will help with the effect, because the effect, as you can see here, will not follow exactly along the spline. Just so you know, this is not a technical limitation. This is for the practicality of the effect and just how it looks. You can feel free to go ahead and change how much your spline is inside of or not inside of your portal mesh. But what I'm going to do is go ahead and close this up, and I'm going to go ahead and look at the spline debug information and just kind of show you what is important to have for a system like this so you can get it to work like this. So as you can see, I have the spline. It is a closed spline, first of all. That's important to mention, so it loops around fully. You can see all of the vectors point, all of the up vectors point outward, all of the right vectors point in this one direction, and the direction vectors obviously go in a circular path here. So look at that one more time. Pretty important to kind of see how they follow this. And so when you're constructing your spline, make sure that all of your points are rotated around correctly so that their vectors there are pointed in the correct direction and you're not accidentally twisting any of those vectors around. Anyways, so that is what that should look like. It can take you a bit of time at first when you're getting used to constructing something like this, but after a while it should go pretty smoothly. And you can make this in any shape you want. It doesn't have to be an oval. It can be any kind of closed blob-like shape. It could really even be open if you want. It doesn't matter as long as its vectors look similar to this and they all point in relatively the same direction. Otherwise, you will start ending up with issues where your particles are traveling in unexpected directions. Anyway, so we can get started on our portal tutorial effect here. So we can first add this to the oval, and we can see there, not sampling the right spot. And so for whatever reason, that came with those already auto-activated. So it's best to just turn these off really quick. And if you're ever having any issues, make sure to go and check your visual effect properties. Make sure properties that shouldn't be on are off. That can fix a lot of issues. Anyways, what we will need to do is, with this system, we will want to send our points. And this, we can see the particles are already spawning off of the spline we have here. We will also be wanting to send vectors and our directions. And we can see that this has propagated itself here, and we have all of these different curves that represent these properties for the spline. Next, what we will do is we will go and look inside of the portal tutorial effect here. And so right now we just have a follow spline, just using random spawning to get it to spawn on that spline. And that's a good start, but we can make it better. And so we can do what we did earlier, and we can actually make this into a shape position spline block. We can load that in, put our positions in there, and it should be spawning randomly all over the spline again. This time we're using our different module here. We can also drag out our up vectors and our directions. They're unorganized right now, but I will organize them. So we can plug these in to the module as well in their respective spots. And what we'll see is, when we have these ordered nice here. And now we can also start messing around with the radius since we have those values in there. So right now our radius distribution is random. What I recommend we will do for this effect, first of all, so we can see this much better, is turn up our particle spawn rate. I'm going to turn this up to something like 1000 and the capacity up to 10,000. If your GPU can't handle something like this, then obviously I recommend to have a number that you can handle without frying your computer. And then the lifetime on these is going to be about 0.8 to 1.1. And so if we look at this, we can see now we have particles absolutely just dumping off of the spline and falling downward. And what we can actually do is, they're not going to be falling downward in the portal or moving around really. So we can delete our turbulence and gravity locks. But we can keep our linear drag because they still will be moving through the air in a way. So we want to keep that there. And we can go and check what that looks like. And we now just have this thick ring of particles spawning here. So one way that we can get our particles to act like this is, first of all, we can define a radius from the spline for our particles to be on, and then give them a direct angle to spawn at. So let's just say our radius is something like 1, just 1. This is going to be a lot bigger than it seems. We can set our radius distribution to direct filled. This will allow us to specify an angle and how far through the radius we want our particle to be at. So let's just say I have our particle at 178 degrees. May not notice it right now, but that's because our distance is 0, so we're still effectively sitting at the origin of the spline. So we can move this up to there, and we'll see our particles are now sitting away from our spline on this radius. And now what I want to show here is, if I drag this over here, we can see this spline sitting here, and we can move this angle, and we can actually watch the particles essentially rotate around the spline in its radius. Now this is a good start, but this isn't exactly what we want, because with the radius, the spline has to always curve back onto itself, but when you are making something like this, you actually would need to do 2 full rotations of this to make the radius properly collapse back onto itself. There's a lot of mathematical reasons behind why that happens that are far too advanced for this video. This radius is a good start, but it's not quite what we need, so we can just turn off the radius for now. But it's an interesting possibility if you do still want to have other options. What will happen if you use the radius is, usually one side will be under the spline here, and this is how we will want it for our system. But then at some point it will have to twist over and up the spline so that it can get back to where it wants to be for a starting position again mathematically. But another way we can define a radius is by using the vectors we found earlier from this. So if we look at our spline visualization, we can see that we have these green vectors that essentially define the, if you were to scale this in or out, where it would go. So we can use these vectors, find the closest one of these to where the particle spawned, and then push that particle inward along that vector, and it will be basically as if that particle was in just a little bit smaller version of the same spline. So what we need to do is, those are the up vectors that we're looking at. We will not need our directions anymore since we are not worrying about our radius. We can move these over here, and I'm going to use a operator. I'm going to use the spline tangent operator. Even though these are up vectors, it does function the same for the tangent, believe it or not. And for our T, our shape position spline module will actually set an attribute in our system called initial spline T. And this is where the particle's first T position from this module was. We can get our initial spline T and plug it into there. And then what we'll need to do is we will need to add a divide, because we will not want to move this by the full tangent. That would be too much. Usually, so you will want to divide this by something like -20, negative so it goes inward, and 20 so you get a small number. We will need to add another block here, and so we just want to add the position. So we want to add this extra little tangent position on top of the particle's position that's already there. So we can add this there. You'll see it's doing something, but it's hard to tell what. So let's first add this force that we can see these particles having here. So we're going to add what is called the spline attractive force. And this may seem counterintuitive because it's an attractive force. So you're probably thinking, why would I want to use this? It's going to pull the particles to the spline, not push them into the middle like I'm seeing for the portal. But all you need to do is just set this to a negative number, and then it will actually push the particles away from the spline, because this is just a coefficient that can be any scalar value you want it to be. So we'll first want to get our position X, Y, and the Z, and we will need to plug these into this module here. And I found a good coefficient for this is about -250. This will make sure the negative pushes it away. 250 will give it a pretty good push and kind of help it end up in the middle. So we can save that. And we can see this does not look right. So all these particles here on the edges are exiting the portal, not like this. Now, why is that? That is because our randomness here is not deterministic. And so we're getting random, but that means our initial spline T does not always bear relation to where our particle actually ends up because of that randomness and because of how the randomness works in the Unity Visual Effects Graph. So you need to make sure to check Use Seeded Random, and then this value will be consistent with where your particle ends up. So now we can look, and it is all rushing into the middle, much like we see over here. And now the system really is almost like this system already. All we need to do is just make the particles look similar. So I found, first of all, for size, we can go into size here, and we'll want to set this second key to somewhere about 0.25. Our color, we can go ahead, I will just copy paste the gradient from the other system, but you can go ahead and make any HDR gradient you want here for your particles. So as you can see, I have this HDR I've set up here. I kind of have the particles start from kind of like that white hot bluish color, and then I have them fade out to their redder color, and it looks something like this. You can see it's not quite the same here. Our particles probably could be a bit bigger. Probably set this to something closer to 0.5. See that? That's looking a bit better now. And so this is actually starting to look pretty good. The only difference really is just the amount of particles that there are that are spawning. And all we would need to do is go ahead and turn up our spawn rate. I have a spawn rate on that other one at about 3,000. Again, I don't recommend doing this if your computer is prone to having issues with these particle systems. But anyways, that is our portal system here. And you can do this with any shape, again, as long as that shape meets that requirement that all of its vectors in the debug menu show that it's all pointing outward in a certain direction. As long as that is the case, your shape will always have this effect going on inside of it when you apply this method. So I could have chosen a square for this. I could have chosen even 3-dimensional shapes really will have this same effect as long as you can align them properly. That will take a lot more work though, because aligning this 2-dimensionally is much simpler. As you can see, all the particles just stay on this one plane right here. But again, no, it doesn't have to be an oval. You could do triangles. You could do freeform blobs, anything you really want to do here. So that is the introduction to the Streamline for Unity system, and that is also how you can go ahead and make these neat looking portal effects using Streamline pretty quickly too. This tutorial took a while going through all of it because we're explaining about how all of it works, but if you know how this all works, you can set up a portal system like this very quickly and have something that would normally take you hours, if not days, done in minutes, and it is truly incredibly helpful. I use this a lot myself in my own development, and having something where I don't need to think too much about the underlying structures of my visual effects, but I can just go ahead and make what I'm thinking is truly helpful to have. So I hope you enjoyed this video and found something helpful out of it. If you found this video helpful and informative, don't forget to leave a like, and also make sure to subscribe and ring the bell so you can get notifications from Galacticc Games about all of our new content coming out and any updates on our products or what we are developing. And also don't forget to check out the Galaxy, our Discord community, for anybody that wants to interact with the Galacticc Games community, and you can also interact with people using products such as Streamline there. And so go check it out. People can be just showing off the different interesting things they've made, tips and tricks. You can also get all kinds of reviews about our products there. Really great way to check it out. And also it's very helpful for supporting us here at Galacticc Games. So thank you, and I hope you enjoy using Streamline for Unity.